Welcome to the deep dive. Today we're going to be looking at AI,
Okay.
specifically the challenge of making these powerful models more well efficient.
Right.
Less energy hungry, faster, and all that good stuff.
Yeah, it's a crucial area of research.
For sure.
We've seen amazing progress with large language models, LLMs,
Yeah.
but their computational demands are a real hurdle.
Exactly. And that's where our deep dive topic comes in SageAttention2.
Okay.
It's a new technique from Tsinghua University that promises to speed up LLMs without compromising accuracy.
Wow.
We're going to unpack the technical report and see what this could mean for the future of AI.
Okay, sounds good.
The report dives deep into how LLMs process information.
Mm-hmm.
And a core component is the attention mechanism, which is kind of like how we focus on key parts of a text when we read.
Right.
So the AI is figuring out which parts of the data are most important, like highlighting the main points in a giant textbook.
That's a great way to put it.
Yeah.
Yeah, but here's the thing. This attention process can be computationally very expensive.
Yeah.
Especially as the amount of data grows.
I can imagine.
Think about analyzing a whole library versus just a single page.
Right, that makes sense.
Yeah.
The more data you feed in, the longer it takes to process.
Uh-huh.
The report mentions quadratic complexity as a major bottleneck. What exactly does that mean?
So imagine you're baking a cake.
No.
If you double the recipe, you don't just double the baking time.
Right.
You might end up baking it 4 times as long.
Whoa.
That's kind of what happens with LLMs. And attention, the processing time increases much faster than the increase in data.
So it's not a linear relationship, it's more like an exponential one.
Exactly. And that's why researchers are looking for ways to make this attention process more efficient.
Uh-huh.
There are existing solutions like linear attention and sparse attention,
Okay.
which are like trying to simplify the recipe or use fewer ingredients.
But those approaches often come with trade-offs.
Right.
Like maybe you get faster cake, but it doesn't taste as good.
Precisely. They might work well in some cases,
Yeah.
but they can limit the AI's capabilities. What makes SageAttention2 so interesting is that it aims to optimize the core attention mechanism itself without those compromises.
So instead of changing the recipe, SageAttention2 is finding a way to bake the cake faster and more efficiently.
That's a fantastic analogy.
Awesome.
And they do this through a clever combination of quantization and some precision-enhancing techniques.
Okay, let's unpack those terms. Quantization sounds a bit intimidating.
Think of it like packing for a trip. You wouldn't bring your entire wardrobe, right? You'd choose the essentials and pack them efficiently.
Yeah.
Quantization is similar. It's about representing data using fewer bits, kind of like squeezing information into smaller containers.
Well, wouldn't that mean losing some information, like leaving your favorite shoes behind because they take up too much space?
That's where the precision-enhancing tricks come in.
Okay.
SageAttention2 uses techniques like smoothing to minimize any errors introduced by this data packing. It's
Okay.
like carefully folding your clothes so they fit better in your suitcase.
So it's not just about blindly compressing the data. It's about doing it strategically to preserve as much detail as possible.
Exactly. And SageAttention2 takes it a step further with something called adaptive quantization.
Okay.
Imagine packing a suitcase where you could adjust the size of the compartments based on what you're packing.
Okay, I'm intrigued. Tell me more about how this adaptive quantization works.
Well, instead of using the same container size for all the data, SageAttention2 analyzes the model
Okay.
and figures out which parts are most sensitive to errors.
That's smart. It's like knowing that you can pack your socks tightly, but your delicate souvenirs need more space.
Exactly. And for those sensitive parts, SageAttention2 uses slightly larger containers to maintain accuracy. It's like having a custom-tailored packing system for your AI model.
Wow, this is incredible.
So we left off talking about this adaptive quantization.
Right, like fitting those different size containers based on what you're packing.
Exactly. And how SageAttention2 really personalizes it.
Yeah, I'm really curious to hear more about how it actually plays out. Like, are there different scenarios where they apply it differently?
You're exactly right. It's not a one-size-fits-all approach.
Okay, good.
For some data, SageAttention2 uses a technique called per-warp INT4 quantization.
Per warp INT4 quantization. Okay, that sounds pretty technical. Can you break that down a little bit for me? What's a warp in this context?
So imagine a group of friends working together to pack a moving van.
Okay.
Each friend might be responsible for a specific box or area. In a similar way, a warp is a group of processing units on a GPU that work together on a chunk of data.
So instead of applying the same 4-bit quantization to everything, SageAttention2 divides the data into smaller portions and applies quantization to each warp individually.
That's a great way to put it. Yeah, it's like having each friend pack their assigned box in the most efficient way possible.
Gotcha.
This finer-grained approach helps maintain accuracy, especially when you have data with a wide range of values.
It's kind of reminding me of packing a suitcase for a trip. Like, you can pack your books really tightly.
Yes.
But those fragile souvenirs need more space.
Exactly.
But the report also mentioned something called per-channel quantization.
Yeah.
For other types of data, what's the difference between per warp and per channel?
Think of channels as different aspects of the data. For example, in an image, you have different color channels, red, green, and blue.
Right.
Per-channel quantization applies this packing strategy along these different channels.
So instead of treating all the data, the same SageAttention2 analyzes the different aspects or channels of the data and applies a specific type of quantization to each one.
Exactly. And this is particularly important when you remember that smoothing technique we talked about earlier.
Right. The one that helps minimize errors by making the data fit better within the limited range of values.
Exactly. Per-channel quantization works hand in hand with smoothing. It allows SageAttention2 to fine-tune the packing process for each aspect of the data, further enhancing accuracy.
This is really sounding like a highly personalized packing system.
It is.
For AI models. But I'm wondering, even with all these techniques, wouldn't there still be situations where using those tiny 4-bit containers leads to some loss of information?
Yeah, that's a really good point. And, the researchers anticipated that challenge.
Yeah.
That's why they introduced another layer of sophistication, adaptive quantization, over layers and time steps.
Okay, so we talked about layers, those different stages of processing in the model.
Right.
Can you remind me what time steps are again?
Yeah, think of time steps like the individual beats in a song.
Okay.
Each beat represents a moment in time.
Okay.
And in a sequence of data, each time step represents a piece of information being processed.
Gotcha.
So, for example, when analyzing a sentence, each word would be processed one after another, each representing a time step.
Okay, so adaptive quantization over layers and time steps means SageAttention2 can adjust the level of data packing depending on both the stage of processing and the position in the data sequence.
You got to imagine having a packing system that could not only change the size of the containers, but also rearrange them.
Oh.
Based on the fragility of the contents and the order in which they need to be unpacked.
That's a pretty powerful analogy, but how does the AI actually know which parts need more careful packing or quantization?
It's like having a built-in quality control system.
Okay.
SageAttention2 actually runs 2 versions of its attention mechanism. One using 4-bit quantization for maximum speed.
Right.
And another using 8-bit quantization for higher accuracy.
So it's like having 2 gears, a high-speed gear for efficiency and a precision gear for accuracy.
Perfect analogy, and here's the really smart part. SageAttention2 constantly analyzes the performance of the 4-bit version across different layers and time steps.
Okay.
It figures out which combinations are most sensitive to errors, like figuring out which boxes are prone to damage if packed too tightly.
So it's almost like the AI is learning how to pack its own suitcase most effectively.
That's a great way to think about it. And for those sensitive combinations, it switches to the more accurate 8-bit version, ensuring a balance between speed and accuracy.
That's amazing. So SageAttention2 is constantly adjusting its approach.
It is.
Based on the specific data and the desired level of accuracy, I'm really impressed by this adaptive approach.
Yeah.
But I'm also a visual learner. Yeah. So did the researchers provide any real-world examples of SageAttention2 in action?
They did. They used SageAttention2 with a video generation model called CogVideoX.
Okay.
And compared the output to using the full uncompressed data. The results were pretty remarkable.
Okay, I'm all ears. Tell me more about these video experiments.
So they gave the AI various prompts, like a cat playing with a ball of yarn or a breathtaking sunset over the ocean. And the amazing thing is that the videos generated using SageAttention2 were virtually indistinguishable from those using the full precision data.
So you're telling me you get the same stunning visuals,
yeah,
but the AI can create them much faster because of SageAttention2's efficient packing system?
Exactly. The speed translates into a smoother and more responsive user experience.
Yeah.
Imagine being able to create high-quality videos in a fraction of the time it currently takes.
That's a game changer for content creators and anyone working with video.
It is.
But even with all these advantages, are there any potential downsides or limitations to using SageAttention2?
Yeah, that's an important question to consider with any new technology.
Right.
While SageAttention2 offers significant performance gains, there are a couple things to keep in mind. First, there's a slight computational cost associated with those smoothing techniques we discussed.
So there's a little overhead involved in making sure the data fits nicely into those smaller containers.
Yeah, it's a tiny fraction of the overall processing time. The speed benefits far outweigh this minor cost.
Okay, good.
Secondly, the researchers mainly focused on implementing SageAttention2 on specific types of GPUs.
Okay.
Those powerful processors designed for graphics and AI tasks.
So there might be some work involved in adapting it to other hardware platforms?
Potentially, yes. However, the core principles behind SageAttention2 are very adaptable, and I'm confident that as this technology matures, we'll see it being used more widely across different types of hardware.
So we've talked about the technical details of SageAttention2.
All right.
We've even seen it in action with those video generation experiments.
Uh-huh.
I want to talk about the bigger picture.
Mm-hmm.
What does this all mean for the future of AI? Where's the field headed?
I think it really highlights a shift in focus,
Okay.
moving from just building bigger models to making existing models smarter and more efficient.
Right.
So for a long time, the emphasis was on creating ever larger AI models.
Yeah.
But those come with huge computational costs.
Yeah, they do.
And SageAttention2 shows that we can achieve groundbreaking performance by optimizing the models we already have.
So it's not just about brute forcing our way to better AI with more and more computing power.
Exactly.
It's about being clever with how we use that power.
It is, and this shift has really far-reaching implications.
Okay, like what?
Well, it could make AI more accessible to a wider range of people.
Interesting.
Smaller research teams, startups, even individual developers
Right.
could leverage cutting-edge AI without needing access to those massive data centers.
That's exciting. It could really democratize AI,
Yeah.
break down those barriers to entry and foster more innovation.
Yeah.
But how do you think this shift will impact the big players in the field? The companies with those massive resources?
Right.
Will they embrace this focus on efficiency, or will they resist it?
I think we're going to see a bit of both.
Okay.
Companies with vast resources will always be pushing the boundaries of what's possible, exploring the frontiers of AI with those massive models.
Right.
And those advancements are valuable. They often trickle down and benefit the whole field.
So those large-scale efforts will still be important,
Yeah,
but they won't be the only game in town anymore.
exactly. The exciting thing is that even those big players are starting to recognize the importance of efficiency.
Yeah, for sure.
They're investing heavily in research to optimize their models and reduce their environmental impact.
Right. It's becoming a priority for everyone.
It is.
So it's a two-pronged approach.
Uh-huh.
Keep pushing the boundaries of what's possible while also making those possibilities more accessible and sustainable.
Exactly. And that duality is what's driving incredible progress in AI right now.
Yeah.
Advancements in efficiency allow us to build even more powerful models,
Right.
which then inspire new optimization techniques. It's like a positive feedback loop.
And then what about hardware? I know we talked a little bit about how SageAttention2 was designed for specific types of GPUs. How important is the hardware itself in this quest for AI efficiency?
Hardware is critical.
Okay.
Advancements in GPUs, specialized AI chips, even new computing paradigms like quantum computing.
Wow.
They're all contributing to the efficiency gains that we're seeing.
So it's like having better tools for the job,
Yeah,
allowing us to build and run these AI models more effectively.
that's a great way to put it, but it's not just about raw processing power. The specific architecture of the hardware also plays a crucial role. SageAttention2, for example, leverages the unique capabilities of certain GPUs to maximize performance.
Right.
And as new hardware platforms emerge, researchers will need to develop algorithms tailored to those architectures.
So it's this back and forth. Hardware advancements inspire new algorithms.
Yeah.
And those algorithms, in turn, drive the development of even more specialized and efficient hardware. It's all interconnected.
Exactly. But even with these advancements in hardware and algorithms, we can't forget the human element in all of this.
That's a really good point.
It's the researchers, the developers, the engineers who are driving these innovations.
Absolutely.
Their creativity and dedication are what are pushing AI forward.
It's true. This entire deep dive has really been a testament to that ingenuity.
Uh-huh.
The researchers who develop SageAttention2 have made a significant contribution, and their work will undoubtedly inspire many others.
For sure.
Yeah, it really does feel like we're just scratching the surface of what's possible with AI.
I completely agree. The journey of AI is just beginning, and it's an incredibly exciting time to be a part of it.
Well, thank you so much for joining us and guiding us through this deep dive into Sage Attention 2.
It's my pleasure.
It's been an illuminating and thought-provoking exploration.
Glad to hear it.
And to our listeners, I encourage you to keep exploring and learning. The world of AI is full of fascinating discoveries waiting to be made.
Absolutely.
And as always, keep those knowledge-seeking gears turning. We'll be back soon with another deep dive into the cutting edge of technology and science. Until then, stay curious.